Alright guys, so today we are starting our linear functions part 1 unit, and we are specifically talking about slope and rate of change. So guys, the rate of change, this is super important. Your rate of change is a ratio that shows how one variable changes with respect to another. Okay? So it's all about a variable that changes in respect to another. On a linear graph, this is called, does anybody know what it's called? Slope. Do you guys remember slope? We did slope. Y'all did slope in 8th grade. It'll come back to you, I promise. Okay? And guys, on a linear graph, it remains constant. This rate of change, it remains constant for any 2 points on the line. So we are going to be talking about a constant rate of change, okay? And that constant rate of change is going to be called slope, okay? And if we want to find this slope on a graph or on a table or between 2 points, we can use different formulas and different things, okay? So specifically today, the variable that's used for slope is m. Does that feel familiar to anybody? M. And m is going to be equal to, we are going to call it the rise over the run. All right? And what this means on a graph is this means, I'm going to make sure, I don't know if I have enough. This is the vertical change over my horizontal change. Okay? So it's your vertical change over your horizontal change. And another way that we can write that, I will probably never write out the words vertical change over horizontal change, just because that's a lot of letters, right? But I will write it out as this right here. Delta y over delta x, okay? And that means the change in y over the change in x, okay? This little triangle right here means delta, okay? Like delta, 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 like tridelts, okay? That means delta, which also means change. So this right here is the shorthand for change in y over change in x, okay? I will probably never write it as vertical change over horizontal change because that's just a lot of letters. I will say rise over run or change in y over change in x. Do you guys feel good about that? And there are 4 different types of slope that we are going to discuss. So on the bottom of your page, if you would like to divide it into 4 sections, you can. Okay? And we are going to talk about a positive slope. We are going to talk about a negative slope. We are going to talk about a 0 slope and an undefined slope. Okay? So those are the 4 different types of slope that we are going to discuss. Now, because this isn't exactly on graph paper, it's not going to be as super pretty, so I apologize in advance. On your graphs on your homework, it will look a lot better. Okay? So I'm going to do my best to kind of sketch out some slopes here. You guys cool with that? So I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Okay, guys. So a line that has a positive slope, this slope increases from left to right. Okay? So I'm going to do, let's see here. I'm going to pick this point and this point. So this right here would be an example of a line that has a positive slope. Okay? And if you think about it, if you were like a little guy walking on a line, he would be able to walk up this line. He would be able to walk positively, starting from the left, going to the right. And how you find your slope is you find some lovely little points and you count the rise over the run. Okay? So remember, our slope is equal to the rise over the run. So I'm going to do some different colors so that you guys can kind of see it. So the rise in this case, if between these 2 points, I go up roughly 1. Do you guys feel good about that? So I'm going up 1. My run would be 1, 2. And because it's going to the right, it's going to be positive. So my slope in this case, M, is equal to my rise, which is +1, over my run, which is +2. So my slope is equal to 1/2. Do y'all feel good about that? All right. My negative slope is going to look a little bit different. So I'm going to draw a lovely little graph for you guys. Okay. So let's see here. 1, 2, 3, 4. 1, 2, 3, 4. All right. So let's see here. I'm going to draw a very negative slope right here. Okay. All right. So if I was a guy walking on this line, would I have to walk down the line? Right? So it goes from up to down. It goes in the negative direction here. All right? And the slope for this, remember, we do what? Rise over run. And the slope in this case, we have a point here and a point here. We would go down 1, 2, 3. So my rise is actually -3. And what's my run in this case? Just a +1. So my slope is equal to -3 over 1. And how would that reduce? That would just be equal to -3. Do y'all feel good about that? Maybe? Yes, maybe so. All right. We have 2 more types of slope that we're going to discuss today. One of them is a zero slope. All right? So, let's sketch a little graph right here. And my line, I'm just going to go straight across right here. Y'all feel good about that? Okay. So this would be a line that has a zero slope. Okay? It's a horizontal line. Okay? Because check this out. If I pick any 2 points on this line, is there going to be any rise in my slope? Will it ever go up and down? No. So, in this case, my rise will be equal to 0 because it doesn't go up. Now, we're just going to count this. 1, 2, 3, 4. My run is +4, which is fine. But 0 over 4 is going to give you what? What will that give me for my slope? 0. So guys, check this out. Even if I picked 2 totally different points, let's say I picked 2 points that were like 10 points away from each other, 100 points away from each other. If I sit here, any number I do 0 divided by 4 gives me 0. 0 divided by 56 will also give me 0. 0 divided by -5 will give me 0. 0 divided by any number will always give you 0. So what this means is that horizontal lines always have a 0 slope. Always, always, always. They always will have a 0 slope. Okay? An undefined slope is going to look a little bit different. So this is true. This will always, horizontal lines will always have a 0 slope. All right. Now we're going to talk about this undefined slope. So I'm going to draw another little graph right here. Okay. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right. So a slope that has a line that has an undefined slope will look like this. Boop. It's a vertical line. Because remember, if our slope is the rise over the run, well guys, can we have a rise in this slope? On this line. Can we have a rise? Absolutely. We can have a rise. So this goes up how much? Let's see here. 1, 2, 3. Okay? That goes up 3. But do we have a run at all? Does it run left and right? No. So this would be 3 over 0. And guys, anytime you do a number divided by 0, it will give you an undefined slope. Okay? If you actually do it in your calculator, any number divided by 0, if I did, in this case, 3 divided by 0, it says error, divide by 0. The calculation fails. All right? If I do, 97 divided by 0, error, divide by 0. Okay? It fails. If I do -42 divided by 0, error, the calculation fails. Okay? You cannot divide by 0. It is mathematically impossible. So our slope is undefined. Another way that you can think about it, so guys, this means that vertical lines, it's not infinite, that the range is infinite, but it's not an infinite slope, it's an undefined slope. So vertical lines always have an undefined slope. Always, always, always. Okay? And you can think about this a few different ways. You can think about it like the guy walking, okay? If I have a little guy who's going to walk on this line, he's going to walk up. So it's a positive slope. If I have a guy on this line, can he walk on this line? He's going to be running, right? But he's going to be walking down the line. Okay, if I have a little guy on this line, can he still walk on a flat line? Yeah. So his slope is 0. If I have a guy here, can he walk on this line? No, he's going to go down and kerplat right here on the bottom, okay? So that means it is undefined, all right? Also, I have a little song for you, okay? So what I want you guys to do is I'm going to pretend for the folks who are watching that this is my arm, okay? So I want everyone to hold up your arm nice and flat, your left arm. Everyone hold up your left arm. Put it in front of you so that you can see it, okay? So we're going to hold it like this, okay? And then, so this is my 0 slope. And then tilt your arm up a little bit. That's your positive slope. Then tilt it all the way vertical. That's your undefined slope. And then kind of break your arm a little bit and go back. And that's your negative slope, okay? So the way this goes is it only works with your left arm because you're looking at it, when you look at it, okay? So you go 0, positive, undefined, negative, 0, positive, undefined, negative, 0, positive, undefined, negative. That's the slope of a line. All right? So here we go. I'm going to do it one more time with you guys, okay, with my arm. Okay, guys, ready? 0, positive, undefined, negative, 0, positive, undefined, negative, 0, positive, undefined, negative. That's the slope of a line. All right? Now, guys, I'm going to tell you right now, it's a little silly, but guys, the two slopes that people mix up the most are the 0 and the undefined. Those are the two slopes that they mix up the most. Because you're like, wait, horizontal, is that 0? Is that undefined? Which one? Guys, so remember the little ditty? You start with 0. 0, positive, undefined, negative. Okay, guys? So if you start with the little ditty, it will help you with that. All right? So that right there is how we remember the different slopes of a line. You guys feel good about that? Excellent. Okay. Now, guys, sometimes we are not given a graph for our slope. You will have, I think, like 6 problems on your homework where you're given a graph. But sometimes we are not given a graph. Sometimes we are given 2 points or a table. So, guys, when we are given 2 points or a table, you use the slope formula dang it, sorry. We're on a new page. Sorry, guys. So those were all the graphs. If you want to do this on the bottom, you can. When finding, so you use the slope formula when you're finding the slope between 2 points. Okay? Now, hold on just a second. I'm going to go backwards. I'm sorry. As you write this down. Now, guys, does it matter which problem you start with, or which point you start with when finding the slope? It doesn't matter, because the negatives are going to work themselves out. I'm sorry, guys, I forgot to do this one. Alright. So, guys, it doesn't matter which point you start with, because if I start it with the left point, I go up 1 and right 2. So that's positive 1 over positive 2. If I start with my left point, I would go down 1 for negative and left 2. So it would be a negative over a negative. What would that still give me? Positive 1/2. So guys, it doesn't matter if you start with a point on the left or the right, because the negatives are going to work themselves out. Like if I start up here and I go down 3, that's negative 3. To the right one is positive 1. But if I go up 3, that's a positive 3. Left 1 is negative. So it's still 3 over negative 1. So guys, it doesn't matter which one you start with when finding it there. The same is true when finding your slope between 2 points. So guys, I'm going to list 2 points. Now, guys, this should be sort of familiar to you guys, okay? This should not be anything that's brand new here. If I have x1 and y, that's x sub 1 and y sub 1 as a point, and then over here, if I have x2 and y2 as a point, my slope formula is m. I'm going to go here. M is equal, this should feel sort of familiar. You should have done this before. y2 minus y1 over x2 minus x1. Does this feel familiar? You guys should have at least been exposed to this in 8th grade, okay? This is on all your formula charts and all this stuff, okay? So guys, here's the deal. All this is saying is it's the change in y. It's the difference of your y's. So that right there is the change in y. And then over, what's on the bottom? The difference in your x's, which is the change in x. So this right here is just a formula that defines the change in y over change in x. Do y'all feel good about that? Because we're just subtracting the difference in our y's over the difference in our x's. Okay? So we're going to do a few little examples right here. Okay? So let's look at example number 1. Okay? I want you to find the slope between these 2 points. We are going to give you -2, 4, and 10, -2. So guys, what I like to do is I like to label my points. Okay? So I go in here and I would say, okay, that's my x1 and that's my y1. This is my x2 and this is my y2. Okay? And then I would actually fill this into the formula over here. And I would say, okay, my m is equal to y sub 2, which is -2, minus y sub 1, which is 4, over x sub 2, which is my 10, minus x sub 1, which is -2. Alright? So this would be equal to, let's see here, -2 minus 4 is what? -6. Over 10, what? Because that's our formula, y sub 2 minus y sub 1. So -2 minus 4. And then we have x sub 2 minus x sub 1. 10 minus -2. Well, guys, if I subtract a negative, what am I really doing? Adding. So that becomes 10 plus 2, which is 12. And what's -6 divided by 12? Can we simplify that? Yes. That will be -1/2. So, guys, a couple things to note. Always, always simplify. Always simplify your fractions. Okay? Always, always simplify your fractions. Because when you when we subtract this negative, it's like it becomes a positive. You can make a really big plus sign out of it. Okay? So now, I'm going to give you guys a couple of minutes here. I want you guys to do, let's see here, I'm going to write example 2, and then example 3, and then example 4. Okay? So let's take a look at these. Alright? I want you to find the slope between these 2 points. So we're going to have -1, -9, and 2, 3. And then we're going to have 5, 8, and 3/8. And last but certainly not least, we're going to do -7, 10, and -7, 5. All right, guys, so I want you guys to find those slopes between those 2 points. All right. So I'm going to pause. I'm going to freeze my screen for a second while you guys do this. Remember, as you are doing as you are finding your slope, make sure that you identify which one is the y and which one is the x. One of the most common mistakes that you guys will make when finding your slope is accidentally mixing up your x and your y variables. And guys, you can pick either point to start with. Alrighty. You getting there? Alright, so you guys should be able to see, we got 4, 0, and undefined. Are y'all able to see that? The biggest thing that's going to get you is subtracting the negatives or making sure your x's and your y's are in the right spots, alright? Those are some of the biggest ones. Alright, so how do y'all feel about this right here, finding the slope here? Y'all feel okay? Okay. So now, this is all how you find the slope between 2 points. So now what I want us to do is I want to find slope from a table. Okay? Anybody have any questions about these 3 examples, the 2 points? Okay, or I guess 4. No? Okay, so now we are going to work on finding slope from a table. Okay? And guys, when you find slope from a table, this is where it's really nice to look at and say, oh, my slope is the change in y over the change in x, the delta y over delta x. Okay? So I'm going to write 2 tables. We're only going to do 2 examples for a table. Okay? So if you guys want to kind of give yourself like a little middle barrier, you can. Okay? So this is going to be my example 1, and then we're going to have example 2. All right. So this particular table, I'm going to write it out like so. I'm going to do a horizontal table. Okay, so we have x, 1, 2. There we go. So this is my x and this is my y. Let's see here. We're going to have 12. And then I'm going to do 24, 48, and 84. Okay? And then my y's are going to just be 1, 2, 3. Oh, nope. That's not 3. My bad. Sorry, y'all. Got a little excited. That's supposed to be a 4 and a 7. 1, 2, 4, 7. Okay? Example 2, we're going to do like a vertical table. Okay? So I'm going to do this one up and down. If you want to go ahead and draw it, you can now, so we don't have to worry about it later. Okay? So I'm going to do my X and my Y. And I'm going to say, let's see here. Alright, I'm going to do 2, 3, 6, and 8. So we are going to go 14, and then 21, and then, hold on just a second. I'm changing my tables from the last one. This one is going to be 56. And this one is going to be 42. Okay? So we have 2, 3, 6, 8, 14, 21, 42, 56. Okay? So what we want to do on both of these is we want to calculate our rate of change. Okay? So, over here, we are going to look at the change in the y's first. So what's my change in my y right here from 1 to 2? We adding, subtracting, what are we doing? We are adding 1. Do y'all feel good about that? What is the change in my x's? 12 to 24, we are adding 12. So, my slope is going to be, remember, delta y, the change in y, over the change in the x. So in this case, what's my change in my y? Plus 1. What's the change in my x? Plus 12. Alright? So my slope is equal to 1/12. Do y'all feel good about that? Now this is what's pretty cool though, guys. Because it's a linear function, that means my rate of change is constant. So guys, I could have picked any 2 points to find the difference between. So look at this. Let's say I picked between 2 and 4. What's my change in my y between 2 and 4? What am I adding now? Plus 2. What's the change in my x right there? Plus 24. Guys, what is 2 over 24? It's still 1/12. So if we did it with this second set of points, it would still give you 1/12. Isn't that cool? So guys, even if you don't always have to pick the same points. Alright? Also, take a look at this one on the last one here. What's the change in my y's? Plus 3. So that would be a plus 3. What's the change in my x? Ooh, between 48 and 84, I think it's what? 36. Yeah, you said that, sorry. So what is 3 over 36? What does that reduce to? 1/12. So it doesn't matter which 2 points you pick, okay? You just have to be consistent, all right? That's how we know it's a linear function, because that rate of change is constant. Pretty cool, right? So over here, for example 2, you can pick any 2 sets of points that you want to find the change in. So let's try it between 3 and 6. Are you guys good with that? Kind of right in the middle? No? You guys want to try something different? Which one do you want to do? Okay, Stina, you're the one talking, so you get to pick. Which point should I start with? This one right here? Okay. Usually if you're changing your x's only 1, that's kind of nice, right? So that's a plus 1. What's my change in my y over here? Plus 7, right? So that means my slope, which remember is delta y. You don't have to write all this, but I'm writing this for you guys. Delta x. So my slope is going to be equal to plus 7 over plus 1, right? Which reduces down to what? My slope is equal to 7. Would that have worked if I picked any other 2 points on here? Absolutely. Like between 6 and 8, that's a plus 2. Between 42 and 56, that's plus 14. Well, guys, what's 14 divided by 2? 7. Over here, I think it would have been what? Plus 3 and plus 21. Well, what's 21 divided by 3? 7. So every time it works, even if you use the different variable, or even if you pick the different points. The biggest thing that you have to remember is y, the change in your y, always goes on top. The change in your x always goes on the bottom. That is going to be the biggest way, or one of the biggest ways that you guys accidentally mess this up, is you would do, like over here, 12 over 1 instead of 1 over 12. So guys, delta y, the change in your y is always on top. Do you guys feel good about this? Excellent. Okay, we got a little bit more to do. I know. All right. So guys, next I want to talk about unit rates. All right, guys, this one's going to be pretty quick, actually. Okay? So when we have a unit rate, this will help us. What does the rate of change actually mean? What does the slope, right? Because the rate of change, another word for rate of change is also slope. So what does that slope actually mean? Okay, guys? So the unit rate, or the rate of change, helps us understand what it actually means. So guys, if we are sitting here and we are looking at something and I tell you, oh, I just went to the bookstore and I spent $84 for 4 books that I just bought. Okay? I spent $84 for 4 books. What would you tell me? What would be the unit rate in this case? I like it, okay? So this would be, we want to think about the change in your y. So this would be the price or the cost per the book. Does that make sense, y'all? It would be the cost per book. So in this case, what is my cost per book? What would it be? It would be what? Yeah, if we did $84 for 4 books, that's going to give me $21 per book. So we are thinking cost per book. Okay? So that's like if we did a verbal problem here. Let's do another one. Let's say I drove 420 miles in 7 hours. So what would be my rate of change here? Well, guys, this would be miles per what? Hour. Also, what do you notice? Guys, time is always x. So if you have a time, it's probably always going to be the x. So how many miles per hour were we driving? 420 divided by what? 7. So how many miles per hour? That would be 60 miles per hour. Do you guys feel good about that? Okay. If we just look at a couple little graphs here, sometimes, guys, they'll give you like a nice little pictograph and they're like, what does this actually mean? All right? So let's say they tell you that we are going to write a graph of a ticket sales, the number of ticket sales over the cost. or the cost of tickets over a certain period of time. Let's see here. So I'm going to draw a nice little, this is just kind of a fake little thing. Well, guys, what would be my unit rate here? This would be what? The cost per ticket. Okay? A couple things to note, or you could also write it as the cost per ticket. Okay? A couple things to note here on a problem like this is the cost. If you have a cost, it's usually going to be in your y variable, your y values. If you have time, it's usually going to be in your x, or your time will always be x. Okay? Do you guys feel pretty good about this? So we always do the y over the x. All right? Y over x. Y'all feel good? All right. So last little section here today, we are going to be talking about slope-intercept form. Okay? So your slope-intercept form is y. Does anyone know your slope-intercept form from 8th grade? Ooh, I'm hearing some good conversation. Okay. All right. Good. Good job, McCullough. All right, so here we go. We have y equals mx plus b. All right? We are going to talk about slope-intercept form. So, guys, in this case, this m represents what? Your slope. Or, what else can we call it? The rate of change. Okay? It is always, 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 always going to be the coefficient to your x. So whether it's the first or the last term, if it's connected to your x, it's your slope. All right? And then your b, okay, it gives you a little bit of a hint that we have slope in the name. Mathematicians are not very creative when it comes to naming things sometimes. Slope. Ooh, we know it's an intercept, but what kind of intercept? There we go. So this is your y-intercept. Okay? So this crosses the y-axis at 0b. And if you're doing like a word problem, then the way that this often is like it's your initial, it's your starting point, your initial value, different things like that. What you start with is usually going to be your y-intercept in like a word problem. Okay? So, if I give you a problem where I tell you, let's see here, if I give you the slope of, let's say, the slope is going to be equal to 2/5. Are y'all good with that? 2/5. So my slope is going to be equal to 2/5. And my y-intercept is equal to, let's say, -2. Are you guys okay with that? Okay. My y-intercept is -2. Can I write an equation from that? Absolutely. And my equation will be y equals, what's my slope? 2/5 x. And then what do we do here? My y-intercept is -2. So it's going to be -2. Y'all feel good about that? So that's 2/5 x minus 2. Okay? Very nice. All right. So, let's say on a problem, now we're going to draw two little graphs, okay? So, I'm going to draw one here. Okay? And I'm going to mark off my points here. 1, 2, 3. You guys good with that? Sorry, I'm going to move it up. Okay, so my line is going to go right through the origin. Okay, so if I needed to find the slope of this line, well, I would pick a couple points here. I'm going to pick maybe this point and this point. Y'all good with that? Okay. So, my rise, what's my rise, y'all? It's what? -1. What's my run going to be? +1. So my slope in this case would be a -1 over a +1. So what is my slope equal to? -1. -1 divided by +1 is 1. What's my b on a problem like this? Oh, where does it cross the y-axis? 0. So in this case, my b is 0. So if I have my b and my slope, can I write an equation? Absolutely. So that becomes y equals -1x plus what? Plus 0. So if we were going to simplify this, I would write my final equation as y equals -x. Okay? Y'all feel good about that? Ish? Alright, now last little problem here. You are going to have to write an equation from a line a few times, okay? So here we go. I'm going to draw another little graph for you guys. Oh no, my ink smudged. Alright, so now I'm going to do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, cool. So I'm going to draw a little line, and I'm going to do one of my points up here at the 4. I'm going to draw one of my little points here at the -2, 1. Okay? So my line is going to go through about right here. Okay, when you're looking at this, is my slope going to be positive or negative? Positive. So guys, that's a good thing to always think about. So in this case, my slope is my rise over my run. So I'm going up 1, 2, 3. So my rise is 3. And what is my run? 1, 2. That's a +2. So that's +3 over +2. So my slope is equal to 3/2. Y'all feel good? Then, what is my b? What is my y-intercept? Do we see it? It's right up here at 4. Do y'all see that? Your y-intercept is up there at 4. Okay. Now that we have our two little guys here, can we write our equation? Absolutely. Y is equal to 3/2 x plus 4. So this would be our final answer. We don't need to simplify it at all anymore. And that is the end of our notes for today, guys. So right now, I want you guys to go ahead